Hi everyone, welcome to Algebra 2. In the last video, we started reviewing for the topic. So we're going to continue reviewing topic 1. But this is lesson 1-1. Key features of functions. So in the first lesson, we talked about domain of a function and the range as well. We talked about what is a function and what is not. We talked about the points. So we want to see the features and be able to identify how to describe the functions, describe the key features of functions. So let's look at the quick review. The domain of a function is a set of input values or x values. The range of a function is the set of output values or y values. These sets can be described using interval notation. Do you remember? So interval notation is describing your intervals using parentheses, right? And 2 commas. So the starting point and the last point. Set builder notation. Do you remember the set builder notation? Or this could be brackets. So set builder notation, you have, you can describe, for example, x, and then inequality, all positive. So this is an example of a set builder notation. Okay, inequality and your variable. A y-intercept is a point on the graph of a function where x is equal to 0. An x-intercept is a point on the graph where y is equal to 0. An x-intercept may also be a 0 of a function. So these definitions are very basic. But if you don't know these definitions clearly, then it's really hard to understand important key topics. Key concepts. Let's look at the example. Here we see a linear line and you see a negative slope because it's decreasing, right? So finding the zeros of a function is easy if you just look at the graph. You are going to identify the x-intercept. That is your 0 of a function because we're finding the value of x when y is equal to 0, right? So there we are, 1, 0. So we found the 0, then determine over what domain the function is positive or negative. So this is decreasing throughout the entire function, but it's only positive when y is positive. So this part is positive. Okay, positive and increasing are different things. Okay, positive and this part is negative. Okay, so the point where the line crosses the x-axis is 1, 0. So this is your 0. X equals 0. X equals 1 is the 0 of a function, and then you can use the interval notation from negative infinity until 1. So everything less than 1 is positive. Okay, and then everything greater than 1, so 1 through positive infinity, is negative. Okay, so remembering our lesson 1, let's solve practice and problem solving questions. Identify the domain and range of the function in set builder notation. Okay, find the zeros of a function. Then determine for which values of x the function is positive and for which it is negative. So we're gonna find all these key features of the graph. So let's look at number 7. We see a piecewise defined function because because we have different parts, different functions over the intervals, right? But then this graph starts here and it does not include this point when x is equal to -5, right? So your domain, when you use your interval notation, is going to be a parentheses, not bracket. Okay, so using interval notation, your domain and range would be -5. So domain is until -5, and then it keeps going on. That's the error, right? Until positive infinity. But how do you write this in set builder notation? You can use this big bracket and then write the inequality where x is greater than -5, and it's not equal to -5. So that's your domain. Okay, and then your range, look at all your y values. It starts from -4 and then it ends at 1, right? So from -1 to 1, including -4 and including 1, that's your range. So your range in set builder notation would be y is greater than -4 and equal to -4 and less than equal to 1. Okay? And so your range in interval notation would be including -4 and including +1. And then let's find the zeros of the function. Zeros would be whenever your function is equal to 0, but you need to find the x value for that. So whenever y is equal to 0, so your x-intercepts, in other words, okay? So zeros of the function, in other words, it's the same as the x-intercept. Why do we have multiple ways of saying it? Because it's used in different ways, but it's actually the same thing. I don't know why my keyboard is not working really well. Okay. My tab. Okay, there we go. And then, so your 0, so this is part of your answer. And then the 0 for number 7 would be x is equal to zeros. X is equal to +1 and +3. There you go. Okay, and then you need to find where it's positive and where it's negative. So your x is used to describe your intervals where it's positive and where it's negative, but you're looking at the y values where it's positive and negative. So your function is positive here. Okay, and then everything else is negative because your y value is positive here, and then everything else is negative. So it's positive when it's from +1 until 3, right? So you can just write the interval. And then your function is negative when it's from -5 until 1 and 3 to positive infinity. Okay, so you can write the interval like that. Okay, it looks like a mess, but if you follow through my explanation, you should know what they all mean. Okay, let's look at number 8. We're doing the same thing. Let's identify the domain and range using the set builder notation. So your domain is all the possible x values, right? Your x stops here. It cannot go left from -5. So it's very similar. Our domain is the same. Using the set builder notation, your x is greater than -5. And this is also to positive infinity. So that's your domain. And then your range, all the values for the y values, right? Your y value starts from -4, and also maximum is also 1. So your range is the same as well. So it starts from -4, including -4, and ends at 1. Okay, same domain and range. That is our first answer. And then zeros. Your zeros, it's just 1 0, right? So when x is equal to positive 2, it's your function has a 0 there. When is your function positive? Your function is positive over here when your y values are positive. So anything above your 0, y equals 0 line would be positive. So, but you need to describe using your x values, right? Your y is positive here, but your y is positive when x is greater than 2. So 2 comma positive infinity would be your positive interval. And your negative would be from -5, right? Everything else is negative. So your y is negative when your x is from -5, not including -5, until 2, not including 2, because at 2 it's exactly 0, and 0 is neither negative or positive. Okay. So we're done with 7 and 8. Good. Let's look at number 9. Sketch a graph given following key features. We have domain is from -5 to 5, and it's decreasing from -3 to 1 when x is -3 to 1. And then we have 2 x-intercepts, and it's also positive from -4 to -2. So let's start with drawing the easiest one, which are the x-intercepts, right? So we know the function is 0 at -4 right here, and then -2 right here. Okay, but your domain is from -5, so your graph still has something before -4. But your graph is positive from -4 to -2. So, and it's decreasing from -3 to 1. So it's gonna go up, and then it's gonna start decreasing from 1. Okay, exactly 1. And then you need to intersect at -2, because that's your x-intercept. And then you don't have the y value, you don't have the range, so you could go as tall as possible if you want, but it needs to look something like this, okay? And you can't have different x-intercepts. And then yeah, any graph that looks like that, but at exactly -3, your graph needs to start decreasing, okay? So I'm gonna make this a little bit straight. Okay, and then let's see. And then it's positive from -4 to -2. Okay, we've done that. We've done the x-intercepts, and we're still decreasing until x is equal to 1, right? So we're decreasing, keep decreasing, and then your domain is -5 to 5. So if it's not decreasing from after 1, then it needs to start increasing, right? So 3, 4, 5 until here, and it cannot go above y equals 0 line, because it's only positive from -4 to -2. Okay, so you can end anywhere below, or you can end exactly at 0, but there needs to be a line that is increasing from exactly x is equal to 1. Okay, and then here you can just have anything that is decreasing as well, that is increasing as well, because it's only decreasing from -3 to 1. So this part needs to be increasing. Okay, and your graph ends at -5, and it's a empty circle because your domain is not including -5, not including 5. So wherever the endpoint is, I'm going to go with this line. You need to put the endpoint here. Okay? If your endpoint is here, you need to put the endpoint, empty circle. Okay? So the graph needs to look something like this. All right, that's number 9. Number 10, Jeffrey is emptying a 50 feet cube container filled with water at a rate of 0.5 feet cube per minute. Find and interpret the key features for this situation. So, let's imagine this. He has a container, and it has 50 feet cube, filled with water at a rate of, it's emptying, so it's decreasing, right? At a rate of 0.5. This is a speed per minute. So if you were to graph this, you start with 50 feet cube, right? And then it keeps decreasing at a slow rate, 0.5 feet cube per minute. So every minute it decreases 0.5 feet cube, right? And so your domain is going to be from 0 because it's not going to be negative, right? So that's where your x value starts. And then you need to figure this point where your Jeffrey is completely done with emptying his container. So let's look at how many minutes would he need, right? Because your x represents number of minutes. Your time in minutes. And then your y represents the volume of water, right? In feet cube. And then, so this is 50. And so you want to figure out how many minutes would you would need. So using this rate, 0.5 feet cube per minute, you want to figure out x minute when you've emptied all 50 feet cube. So you can make a proportion like this, or you can just make an equation. In equation, you would get something like 0.5x is equal to 50. This is 1, okay? And then if you figure x out, it's just 50 times 2, right? So x is 100. So that means your graph is going to have an x-intercept at x is equal to 100. So x 100, 0. So that is your domains from 0 to 100, and it's going to include 0 and 100 because it's part of your context. When time is exactly at 0, that's when Jeffrey didn't even start emptying. So it does mean something. And when it's exactly 100, he's emptied everything, right? So that's exactly the point when he emptied everything. So yes, it includes 0 and 100. So your domain will be, I'm gonna use the interval notation, from 0 to 100 with the square bracket. And your range, identify the range as well. Yes, it's gonna be starting from 0 to 50. Yeah. Your volume of water cannot be negative because in this situation, it's not gonna have a negative volume. It's always going to be positive. Okay, and is the graph increasing or decreasing? It is not increasing anywhere. It's only decreasing throughout. So decreasing. I don't know why it's so hard to draw, so I'm going to type decreasing from 0 till 100, or throughout the whole graph, right? And I'm also going to mention that it's not increasing anywhere. So increasing none. Okay, so those are the two things that we got started: domain and range, increasing, decreasing. We also want to find out the x and y intercept, and where the graph is positive and where it's negative. So your x-intercept, let's write it here. X-intercept is when the graph crosses your x-axis, which is at 100, 0. And your y-intercept is when the graph crosses your y-axis, which is your starting point, 0, 50. Okay, so remember that your domain and range, the bracket, is your interval notation. X-intercept and y-intercept is your coordinate point. So you can write the coordinate, or you can just say 100, or when x is equal to 100. And then y-intercept, or you can just say 50. Okay? And then let's talk about positive and negative as well. Where is your graph positive? The graph is positive throughout the entire graph, right? So you can write the interval notation from 0 to 100. And when is it negative? It is never negative, so it's none. Okay? So these are the key features that you're going to talk about whenever you interpret the key features. Okay? So domain and range, increasing, decreasing, and then x-intercept, y-intercept, and positive and negative. Okay. All right, so that was a summary of lesson 1. If you feel like you didn't understand everything, then it means you need to go back to lesson 1 and review. All right, in the next video, we'll review lesson 2.